today about we're building on what we're doing. This time we'll have an algebraic expression written for us. We've been working on writing them from scenarios. We're building on it. Now, once we have an algebraic expression, we're going to evaluate it for having more information. So this is what we were talking about. If I had something like a minus 2, I really can't tell you any more about the situation unless I get some more information. I could find out later maybe what it's equal to, then I could tell you what A is. But for right now, we're going to be talking about what happens when you know what the variable is. So your book is saying things like evaluate an expression. It's using words like evaluate the expression. Means give me the number when we can consolidate for the variable. For the given value of the variable. I do want to take a minute here because sounds like a simple direction, but these words mean things. So evaluate means really like solve, really means to solve it, to find an answer. The expression means that there is no equal sign. So I'm going to be given something with no equal sign. For the given value means that it's in the problem. It's stated. It's given to me. And the given value of a variable which can change. It can change, and we're saying, so basically what this is saying is if the variable is equal to this number, then what is the expression? So if the variable is equal to the given, then what is the expression? What is the value of the expression? So thinking about an if and then, because remember, an expression of algebraic expression can have a lot of different solutions depending on what they are. So we'll start with an example. So if I had something like 4x, well, x could be a lot of different things. It could be whole numbers, it could be negative numbers, it could be decimals, it could be fractions, it could be a lot of different things. I don't know anymore. But if you tell me x is equal to, and I just want to just see if there's anything fancy in the book, x is equal to 8. So if x is equal to 8, then what I want to do is I want to substitute. I want to take the 4. And remember, this 4x really means 4 times x, which really, I like to put the parentheses in there. It really means 4 times, what's x this time? 8. I really wouldn't squish 4 and 8 together, because if I squish 4 and 8 together, it looks like 48. It does not mean 4 times 8. So if I want to mean 4 times 8, I have to put either with the parentheses or without the parentheses, that multiplication symbol in there. But if I have a number and a variable squished together, it means multiply. So 4 times 8, that's 32. So how I would read this is, if x is 8, then 4 times x is 32. But if x is something different, then 4 times x would be something different. So I want you to be thinking about that as an if-then. Mrs. Nelson, did you want to add anything?
So far, so good. You know, I love these if-thens. I really like them. We use them in, what's that program that we do for SEL? It's been so long. Second step. So we use if-then statements in second step. We use it in real life. If I do this, then that is going to happen. It's a way to make decisions and look at consequences. So I like that it's used here in math. If-then. And that creates, you know, more discussion as we move forward into lines, algebraic drawing lines, and function tables, which are a big part of what we do next.
So this chapter, we're giving you an n. later we're building on where you can choose your end, and that's what we're alluding to when we're graphing things. So again, I have an expression and it wants me to evaluate.
Does anybody know right now how we might evaluate this one? Or what property is being exhibited there? We talked about the commutative property not being in subtraction and in division. What property is being used here?
What does this mean actually anyway? What does it mean? So I have a 3 outside of parentheses. That means I have 3 of these parentheses. I have 3 of them, right? Because it means multiply whatever n plus 1 is. I have 3 sets of them. Well, if I had 3 sets of them, I would have 3 n's and I would have 3. So I can think about that this way, or I can, and then I wouldn't have to worry about order. Well, then the order of operations, it looks a little different than here.
Because the 3 is being distributed over onto the n. It's being given to the n, and then it's also being given to the 1. So 3 times n plus 3 times 1.
Because it's 3 of n plus 3 1s. Perfect. Yeah.
It's the distributive property. Anyway, I'm sorry, I digress.
That's good. That's a perfect digression. So here we go. If n is 5, first thing I want to do then is to substitute. So I should start putting my steps in here. First thing is to write the expression.
Oh yeah, good idea. Was Bob in there yesterday?
Second thing would be to substitute the variable for the value, for the given value. This time the problem gives it to me, the given value. In math, we call it the given. And then we use order of operations to solve. Order of operations to evaluate or to solve or to simplify.
Or evaluate.
Yep. Solve, evaluate, simplify, all of those things mean the same. I want to find what that number is. So I've written it down. I did double check it because I know you keep seeing my head go back, double checking it. So the next step is I'm going to write the expression. I'm going to do it in 2 different colors. So I'm going to write 3. And instead of putting in n, they told me, what would it be if, what is it if n is 5? Well, now I've written it down. Now I'm going to use order of operations parentheses first. 5 plus 1, so the 3 stays there. 5 plus 1 is 6. Remember, this means 3 times 6. 6, 12, 18. The answer is 18. And I would say if n is 5, then 3 times the quantity of n plus 1, that's how I'd read it, times the quantity of n plus 1 is 18. Lots of practice saying the terms. If n is 5, then 3 times the quantity n plus 1 is 18. Sometimes an expression has more than one variable. I want to try one more problem. Sometimes an expression has more than one variable. I want to put that right up in here and just try and do it in the middle part so we can leave that bottom. Try to get that here. And then then in that case, the problem will give me a value for each variable if I'm going to be able to evaluate it. So that's another thing that's happening. So, but sometimes they have 3 variables, like one of the problems that you have here, where we have BC minus 5A, and they said to evaluate it where A is 3, B is 4, and C is 6. Okay, first step, I wrote the expression. Next one, I'm going to substitute the variable. Oh, it looks like I could have variables for the given value. So B is 4. I'm going to put 4. Remember, BC means B times C. And this time I better put that multiplication symbol. Otherwise, I might think I'm writing 46 and not 4 times 6. And I just learned it just kicks out at me so much better if I put the parentheses around there. I don't make that mistake of losing that multiplication symbol.
That is my favorite mistake, though, when I'm grading, you know, papers like this. That's my favorite mistake, when the 4 and the 6 are there as a 46, because the students understood that they had to do the substitution, and then all I need to do is teach them that it's not to make a digit, that it's to make a multiplication statement.
4 times 6 is 24. As I'm doing that, I'm thinking, making sure it still is. Minus 15. So now I'm order of operations, do multiplication first. And now I'm into subtracting 24 minus 15. That is 9. So if A is 3, and if B is 4, and if C is 6, then B times C minus 5 times A is 9. The challenge is sometimes the order of operations get more involved. Sometimes the numbers aren't whole numbers, they're decimals, they're fractions, they could be positive or negative numbers, but the strategy remains the same. Writing the expression, substitute for the variable or variables, using order of operations to get it to one term. That is what we're doing now, and we'll be building with it then. Tomorrow, what happens is you're giving words that first you have to come up with the expression and then you have to substitute for. So, what questions do you have? What do you wonder? What would you like to see? Thinking for a minute. Okay.
I was wondering if you put the 5 in on that one problem that we did there, if that would still come out to 18. So n plus 1, n plus 1, n plus 1. If n is 5, right, we could have evaluated that 5, 5, 5. So we would have gotten, each one of those would have been worth 6, and 6 times 3 would have been. Can you write all 3 of those along the bottom? Could you write like the 3 parentheses n plus 1? And then put that that is equal to 3n.
Oh, okay, 3n plus 3.
Yes, 3n plus 3, what you have there. And then could you show what it looks like if it's 3n plus.
See if these are equal, see if these are really true.
Yeah, because lots of times they give us problems like this and they say, are these two equivalent? And then, so then they give you the if, and they want to know if those are equivalent.
So what I like to do when I do that kind of problem, I put the equal sign. I don't mean to cross it out. I mean to just kind of think, let me see what it is on this side, and then let me see what it is on that side and see if I get to the same answer.
Okay.
So 3, and now I'm going to substitute, same strategy I'm going to do. I just have 2 problems to check. I almost just don't even want to look at what's going on over here. So I put the 5 in. Order of operations say to do parentheses first. 5 plus 1 is 6. 3 times 6 is 18. Now I'm going to look over here. This is my expression. Not going to look there because I'm not sure it's equal yet. I'm checking. 3 times n, which is 3 times 5, plus 3. 3 times 5 is 15, plus 3. So that is also 18. So these two expressions are equivalent. That is going to be something you're going to be checking in the days coming ahead too, to check to see if it's an equivalent expression.
Thank you. And since we're not in the classroom and we can't do the activities on that distributive property, I really want students to be able to see that the 3 is being distributed onto that n, and it's also being distributed onto that 1. So that is the distributive property, and it's pretty important property when we're working in algebra. What other questions or wondering might somebody else have? Is anybody there?
There are some more challenging problems coming with the word problems, setting up into problems. I would love for you guys to come back tomorrow when you're working on those. Be hunting for the tricky ones. Be hunting for the ones you want us to try.
All right. And that is our lesson today on algebraic expressions and evaluating using the if-then statement.